What did NASA's Voyager 1 really discover? NASA's Voyager 1 is the first spacecraft to travel outside the Earth's atmosphere. Voyager 1, which was launched in 1977 to travel by Jupiter and Saturn, crossed into interstellar space in August 2012 and is still collecting data. The Golden Record, which is a letter from mankind to the world that contains greetings in 55 languages, photos of people and locations on Earth, and music ranging from Beethoven to Chuck Berry's Johnny B. Goode, is carried by Voyager 1. Hey everyone, this is Sash from Tech Locker. In today's video, we're going to go over what did NASA's Voyager 1 really discover. So without further ado, let's get into it. In September 1977, NASA's Voyager 1 spacecraft launched 16 days after its twin, Voyager 2, from the Kennedy Space Center on its long journey into the unknown. The probe's main purpose was to study the outer planets up close, including their massive moons and strange ring systems. Unbeknownst to the public at the time, these probes will go on to explore uncharted territories and assist scientists in better understanding energy and radiation in space. Voyager 1 was launched on a quicker, more direct path that would send it hurtling towards Jupiter and Saturn, while Voyager 2 would follow a somewhat different path that would take it past the two gas giants but then on to Uranus and Neptune, taking advantage of a planetary alignment that occurs once in every 175 years. Voyager 1 released its first pictures within a few weeks after leaving Earth, one of which shows a crescent-shaped Earth and Moon suspended in space. On the 18th of September 1977, Voyager 1 was 7.25 million miles away from Earth and captured the first image of its kind ever captured by a spacecraft. The moon is visible at the top of the picture, along with the blurry Eastern Asia and the Western Pacific Ocean seen on our blue planet. Voyager 1 only took around 1.5 years to reach the first and the largest gas planet in our solar system, Jupiter, in January 1979. Thanks to the spacecraft's direct path. On its approach to Jupiter, Voyager 1 started taking photographs of the planet, capturing nearly 1900 pictures. This time-lapse captured Jupiter's swirling clouds spinning within bright bands over the course of 60 days, far surpassing any snapshot of the planets ever taken from Earth. Close-up photographs of Jupiter's iconic storm, the Great Red Spot, were also captured in unprecedented detail. The picture shows the swirling existence of the giant storm along the huge white spots that surround it, as well as giving us a closer look at Jupiter's marble-like atmosphere thanks to the use of color filters. Jupiter's thin ring structure, visible as a faint band across the center of the image, was also identified for the first time by Voyager 1. The thin ring around this planet made it the second planet known to have a ring. The ring's edge is about 35,400,000 miles away from the planet's visible cloud deck, and the background stars appear as broken hairpins in the picture because of the spacecraft's motion during the 11-minute exposure. But Voyager 1 didn't only study Jupiter. Many of the gas planet's enigmatic moons, such as the volcanic moon, were also photographed. In this picture of Io, you can see hazy images of the moon's hellish surface, which expose ancient volcanic scars that run through the landscape. Active volcanism had been discovered for the first time outside of Earth on Io, using various camera filters. The massive plume can be seen silhouetted against the darkness of space on the moon's far side. The close-up picture also reveals the moon's vibrant colors, which are thought to be accused by allotropes and sulfur compounds, as well as dark spots that may be lava flows or volcanic craters. Other satellites, such as Jupiter's largest moon, Ganymede, have also revealed their strange surface features, exposing massive ridges, grooves, and impact craters that are scattered around its icy thick crust for the first time. The discovery that Jupiter's atmosphere was more active than it had been during Pioneer 10 and 11 visits prompted a rethinking of earlier atmospheric models that couldn't justify the new features. For the first time, the spacecraft captured images of the moon Amalthea, Io, Europa, Ganymede, and Callisto, revealing descriptions of their terrain. The spacecraft also found two new moons, Thebe and Metis. Voyager 1 completed its flyby of Jupiter and its moons in early April 1979. after months of observing Jupiter and its moons, and moved on to the second largest gas planet in our solar system 20 months later. Voyager 1 eventually arrived at Saturn's ringed world on November 9, 1980. During the flyby, the distorted picture reveals Saturn's dark and light bands of swirling clouds, its enormous magnificence ringlets, as well as two of the gas giant's elusive moons. Titan, Saturn's largest moon, was also spotted by Voyager 1. The enhanced image shows Titan's hazy nitrogen-rich atmosphere, leading scientists to speculate that liquid methane and ethane seas may exist on the moon's surface, which was later verified by the Cassini mission in 2004. Voyager 1 captured this image of the planet's ring system 8 hours after its closest approach, showing hundreds of magnificent bright and dark ringlets made up of trillions of tiny icy particles as well as larger scattered boulders. The Voyager discovered the most surprises and mysteries in Saturn's rings. The rings are thought to have formed when larger moons were broken by comets and meteoroids. The dust and boulder to house-sized particles that resulted have accumulated in a vast plain around the planet, with varying densities. Saturn's 8 smallest moons have odd forms, indicating that they too are remnants of larger bodies. In addition to thin rings and broad diffuse rings not seen from Earth, unexpected structures such as kinks and spokes were discovered. The gravitational effects of surrounding satellites are responsible for much of the intricate structure for some of the rings. The relationship between the F ring and 2 small moons that shepherd the ring material best illustrates this phenomenon. The ring's kinked appearance may be due to variations in the separation of the moons from the ring, except for the tests intended for its photopolarimeter, which did not work. Voyager 1 accomplished all of its objectives. Prometheus and Pandora, the shepherding moons that hold the F ring well defined, the Atlas, which shepherds the A ring, were discovered by the spacecraft. The spacecraft also took images of Saturn's moons Mimas, Enceladus, Tethys, Dione, and Rhea, as well as revealing the intricate structures of Saturn's ring system and adding the G ring to the list of known rings. During its flyby, Voyager 1 collected massive quantities of data and identified 3 previously unknown moons. However, its primary mission was complete, and the spacecraft would never come close to another celestial object again. But even so, at a distance of about 4 billion miles away, NASA directed Voyager 1 to aim its camera back towards the Sun one last time, at the request of astronomer Carl Sagan in February 1990. The Solar System Family Portrait was created from a collection of photographs taken by the spacecraft. The mosaic is made up of 60 frames that, when magnified, show the planets Venus, Earth, Jupiter, Saturn, Uranus, and Neptune. It's the first ever seen portrait of our solar system from the outside. Earth is depicted as a tiny blue speck in a glorious beam of dispersed light in the famous image known as the pale blue dot. Engineers switched off the spacecraft's cameras after all of the images were transmitted back to Earth, so that it could control other instruments as it went on its journey into the unknown. Then, 24 years after its Saturn encounter, on the 16th of December 2004, Voyager 1 passed through the termination shock, an area where solar wind suddenly slows down and heats up as it meets interstellar wind. The spacecraft will have to pass through a turbulent region known as the heliosheath, which is the outer layer of a charged particle bubble that circles the solar system. On August 25, 2012, Voyager 1 became the first human-made object to reach the threshold of interstellar space. The amazing spacecraft, which was only designed to last 5 years, is still gathering data 13 billion miles from the Sun, detecting the maximum strength of cosmic rays outside of a solar system. The spacecraft will have enough energy to fuel its instruments until 2021, according to NASA. It will then travel through interstellar space for 40,000 years until it comes within 1.7 light years of a star in the Ursa Minor constellation. The Voyager 1 is still in contact with NASA's Deep Space Network. The Cosmic Ray Telescope, the Low Energy Charged Particle Experiment, the Magnometer, and the Plasma Waves Experiment are still functioning. Both spacecrafts have traveled more than 11 billion miles from the Sun. Engineers started preparing for tough times in 2019 in order to keep the spacecraft's instruments and thrusters operational for as long as possible. The two Voyager probes have been in orbit for longer than any other spacecraft in history, and we expect they will continue to do so for several more years. Even if the Voyager mission had ended after the flybys of Jupiter and Saturn, it would have provided enough data to rewrite astronomy textbooks. However, having doubled their already ambitious itineraries, the Voyagers returned data to Earth that has revolutionized the science of planetary astronomy over the years, assisting in the resolution of key questions while posing fascinating new ones about the origin and evolution of the planets in our solar system. With that being said, here we come to the end of our video. I hope you liked this video. If so, then don't forget to subscribe to the channel so you never miss any video. I'll see you in the next video. Till then, take care and thanks for watching.